Okay. Hello.
Here we go. We are live. Hello, everybody, and welcome to yet another fantastic session. I'm so happy to introduce Mary for this session. Mary and I were on a panel yesterday having a great conversation about the use of AI. And I'm very keen to hear from you, Mary, about the new world, the brave new world of GenAI with vector search. Now, Mary Grygleski is a Java champion and experienced, a passionate developer advocate, a software consultant. You've done so many things, right? You work for companies like IBM, DataStax. You focus on GenAI, streaming system, obviously Java, open source, a lot of things. Now, without any further hesitation, I'm really looking forward to this session. Over to you, Mary, and good luck.
Thank you, Stefano. Thank you so much, and thank you again to Dev Days. I really appreciate. So, thank you everybody. If you came, let me kind of do this one thing. I need to switch back, and then I will make it small so then I can I won't be like blocking everybody. Yeah, okay. It should be good. Okay, everybody, welcome to my talk. Right? Enter the brave new world of GenAI with vector search. And as such, if you are a science fiction enthusiast, you will recognize the Brave New World title right away. It's by an English author, Aldous Huxley, and very famous book about Brave New World. So I kind of, when I was trying to, come up with a title for my talk, I figure generative AI, ChatGPT, took the world by surprise, right? Everybody was all excited about it. But in Aldous Huxley's novel too, it's basically painted a very dystopian type of culture, right? That's resulted from the future, of our world, in which we're kind of, in some ways too, we have lost our individuality, and it's like controlled by some like world power, all of these things. So it's kind of dystopian, right? Isn't it? Like all of these sci-fi like to say, like the people are suffering. Basically, you have to like, listen to a central power. Now, the thing is too, is that I feel it's kind of somewhat relevant to Gen AI, especially when it first came out, right? It's kind of exciting, and basically we actually got to a point in which we were nervous that Gen AI can take over our jobs. But right now, as such, since its debut, right, back in 2022, November, it's, the ChatGPT 3.5 that came out, we are kind of noticing that, okay, the hype is kind of lifting now. There's still kind of plenty of work to be done. And I myself personally think that it will be here to stay, but then we recognize there are a lot more work in order to make this technology truly usable, truly productive. But that's what it is, right? But let's kind of delve into this world. Especially, I find that there are a lot of developers we have been kind of more used to, right? We're experienced doing things in the traditional way, traditional computing way, the enterprise way, perhaps if you're a Java developer. So we didn't get into the Gen AI yet. So let me kind of introduce to you this topic, and also specifically to focusing on a bit too on the vector search at one section of my talk. So, okay, let's move real quickly and move on to the next page. And who is Mary, right? So this is kind of my kind of blocking a little bit, but you can kind of make out of it here. But this is the agenda for today. I'll do a quick introduction and then giving you some brief background of AI, especially I'm assuming that perhaps, also from my experience is that a lot of you might have started maybe coding some, AI, but it's good to kind of get an understanding of AI first of all, and then understand who are the players in this new generative AI era. And then also I will then introduce to you all of the commonly, that heard of terms like GPTs, NLP, LLMs, and, RAG, and also like the vector database too. And that should kind of fill the space. And then if there's time, I can do a very quick demo as well. And then also share with you, kind of remind all of us too, there are benefits. While there are benefits, there are also like challenges, as I'm kind of like pointing out in here, all these different things. So that's the quick introduction. And let me kind of go straight into really quickly. So who am I? I'm a passionate developer advocate, and thank you to Stefano. He already gave the quick kind of introduction, but these are kind of pictorial kind of explanation of my background, kind of just the key points. I'm doing a lot of things too. These days, I'm transitioning. I'll be starting as a generative AI practice lead for a consulting firm here that's based in the US in Ohio very soon. But anyway, but this is how you can get a hold of me. But I'll be sharing with you my contact information at the end of this presentation too. But primarily too, I'm just very interested in computing. I'm kind of was doing a lot more like streaming stuff back at IBM and as a developer advocate, and then at DataStax to streaming, and then kind of led into this generative AI. But I'm kind of definitely kind of diehard. Started off interested in operating systems, moving on to like distributed systems, reactive systems, IoT, MQTT, real time AI, ML. Those are kind of fascinating to me. Okay, so let me start. Very brief background of AI. So, kind of, if we kind of start taking a look, right, of this, kind of AI kind of revolution, let's kind of, we all probably are aware that it's not completely new. So, as you can see over here, this, kind of like the timeline. And by the way, too, I might be blocking it, but that's the URL as where I kind of got this timeline from. So I will be actually sharing with you my slide deck. So if you miss it, don't worry about it. You can get this full stack too after the presentation. Okay, so let's kind of quickly take a look at this timeline. So actually, one thing I didn't kind of point out in here is that if you kind of do some research on AI, I mean, kind of really strictly speaking too, in some internet literature, basically it says AI, the revolution began, in the BC, like before Christ kind of kind of era, so many thousands of years ago, and it's basically the world at that time. It was designed by a Greek person, philosopher, or called Archytas, and he kind of did like a steam-powered pigeon, right? And so the idea basically is that we want machines to do our job. We want the automation part. But of course, back then it was very primitive way. So let's take a look at the 20th century. As you can see, right, we started off, essentially almost 100 years ago, the 1930s time. That was when, a lot of science fictions came out, right? Golden age of science fiction. And then very soon too, then in England, the father of modern computer science, Alan Turing, came out with this title, Can Machines Think? So it's kind of this whole trend, right? Kind of moving towards, encouraging a lot more research being done. And all of these, first AI program, there Dartmouth has some summer research, project on AI. And all of these things, right, as you can see, I won't kind of get through all of these, but this is quite interesting. And I want to also point out too, actually, I was just came back from Europe from JCon in Cologne, Germany, and one person point out to me was also a perceptron too that he pointed out to me. So if you're interested in that, it's also like a particular kind of research during that time in the 50s too. So I'm going to add that into it in my next slide. But anyway, so if you can kind of like see all of it, and major institute, right, MIT, Carnegie Mellon, in England there, all of the university, Cambridge, Oxford, all of these, and all over. And also then in terms of industry, Deep Blue came out of IBM, and as we all know, Deep Blue is kind of a dedicated machine to play chess. And then it ended up beating Gary Kasparov, the chess champion, in 1997, is actually beaten by Deep Blue. So all of these have sparked a lot more interest into it too. And there's also like, late 20th century already came out with Dragon Systems, was basically the first speech recognition software that's developed by them. So, and this is very interesting. But okay, I see a question. Stefano kind of point out to me, question from the audience. What about ethical stuff concerning AI stealing artists' art? That's an excellent question. And that's something too that in my panel just previously too, we discussed a little bit about like, ethical security kind of stuff. But let me address that a little more maybe towards the end as well. But that's a great question because as such, there are also questions about all of these things. But ultimately, too, if you kind of think about it, we want machines to be, not just automate some mundane tasks. It's basically we want machine to be doing things completely automating, maybe to the point of taking over our intelligence. However, but that's a danger in it too. And also too, if we kind of look at it that way, then I'd say, the present stage of Gen AI is really just at the tip of the iceberg. It's just starting, right? It's far from ready for production, right? And I'll share with you a story later as well as to why I say so. But let's first take a look at some background. So if we kind of look into this AI, there's, especially for folks who may be new to this topic area, just try to get an understanding, right? There's AI, there's machine learning, deep learning, and how do they relate to each other? But I don't think it's very hard to understand right now. If you think of it like an onion kind of shape, there's a artificial intelligence, like basically the onion itself is essentially, right? We try to mimic human behavior and also automate things, and having, the machines having intelligence to even decide what to do and to do the stuff for us. However, on its own, it can't do much. So that's why we get into the inner core of this onion, in which, there's machine learning. So we're getting into the substance, what gives it the power. It's basically machine learning. First, machine learning is the technique by which the computer will learn from who? Not from us training it. It's basically giving it data, have the computer figure out what to do, right? And learning the behavior. And it's that's what it is about training the model from large and huge data sets. It's called corpora of data, the data set, right? Or corpus of data. And the thing is, too, even machine learning itself is not sufficient to solve a lot of the intelligence problems. So that's when we get into the deep learning space, in which, it kind of get into the neural networks. We are basically, a lot of research are being done here, in which is figuring out how does the brain works, right? And how does our brain works, and apply it to machines, and training to let machines to train on itself using this particular techniques is the neural networks. So that's kind of like a very quick kind of introduction to that. And let's take a fascinating look, fast forward to today, the Gen AI era. So let's kind of first understand too, ChatGPT. This whole category of kind of computing is called generative AI, as we all know. And it is a disruptive field in AI. Why is it disruptive? Okay, you might say, well, there are already some things being done. And there were also predictive, what is called like predictive AI. So the difference is that basically predictive AI has already been there. Is essentially to, based on data, it will make predictions, right, of maybe business forecast. What would it look like in 2 years, in 3 years for business, or weather forecast in, like, what does it look like next month, the weather pattern. All of these are very predictive, and it's also trained on, basically you feed it data. So from the data, it kind of derives, what it should be, and then give you the prediction. However, there's a time kind of sensitivity to it, because once the 2 years is over for your business forecast, then it's no longer valid. Now, going to generative AI, first of all, is that we all probably are aware of prompt engineering. It's a kind of a new subfield of profession too, in which, we basically have to prompt, your AI, the robot, to kind of get what we want, so to speak, right? So these are, you give prompts, but also one difference is that there's no need to follow what we call like traditional rule of doing computers, in which, we all know so well, if we write a script, for example, right, a bash script, even a PowerShell script, if you're a .NET person, is you basically have to say, when you do something, you need to give it a set of parameters, and you have to follow strict rules. And so it's very basically robotic kind of way of asking, your systems, your program to do stuff. Whereas for generative AI, there's no need to. You can just ask this machine, this robot, ask it like the way you talk to another human being. So that is a very kind of a revolutionary way. But of course, it's also not all new. It's already, kind of came out with speech recognition by Dragon Systems just now in that diagram. And also, an Apple computer came out with Siri, right, in the early 2010 kind of time frame. So not all new, but the difference is that right now, it's really capable of understanding, human spoken language really well too. So generative AI essentially take the prompts, and then based on that, it does a lot of similarity searches, and basically from its algorithms in the models, is able to figure out what you need. It's basically what is called like chat completion, right? So, and it produces the contents for you. So the creative thing about generative AI, or I should say, generative AI tends to be all more on the creative side, because, for example, we want to write an essay, which kind of have been wowing all of us, and these days, I think even like students might be using ChatGPT to write their essays, or us too. We work in the industry. We need to, or marketing, need to write a promotion. We can actually ask ChatGPT to provide us with the content. But very often, though, we know you can't just fully be depending on the ChatGPT. You still need to do some kind of fine tuning to it. But for the most part, it does its job very well. And also, basically too, you can also like do text to image, right? You can describe a scenario, have Dolly, Mid Journey, all of these to generate picture for you. So that's kind of like the generative AI thing that's kind of exciting. So really quickly too, let's take a look, right? All of the, how does it kind of came to being? And we can kind of go back to 2003. The first feed forward neural network by Yosha Benjo and his team developed that first language model that's kind of like pointing towards the direction of this chat GPT. And as such, I mentioned about 2011, Apple brings AI and NLP assistance, like natural language processing assistance, to the masses by releasing its first Siri on its iPhone too. And then 2013, a group of Google researchers by Thomas Mikaloff created word to vec. And so that's actually an important kind of research being done. And it's basically formed the basis of the today's, especially like vector database, vector search, because it's essentially looking at words and convert them to vector data as such. So it's kind of formed the basis of vector database. And then 2017 is basically, there's also another paper at Google. It's called the transformer. Now, if you have been following some of these papers, all of these, you might have heard of attention is all you need. So that's where that came out of this paper from. It's basically the transformer too. So it's basically the transformer is a simple network architecture that supports all of these kind of like essentially gearing towards the generative AI era too. Okay, so now after kind of a quick understanding of Gen AI, let's take a look at all the players. I think it's also very important too, who are, kind of in this field. Now, first of all, with generative AI, we have all heard of the LLMs, the models too. So these are generative models. So I like to kind of point out to you too, these are some of the more popular models too. And of course, there are more too. And don't get me wrong, these are just some of the more popular ones that we hear about. So first of all, OpenAI, we all know, is kind of like the de facto kind of organization, right? That's kind of in charge of all of these Gen AI model. And first of all, it came out with in 2022 November that wowed the world was the GPT 3.5 model. And then then kind of it's also along the way, it isn't like the first thing. But if you kind of look over there in the corner is BERT. And it's interestingly, BERT stands for bidirectional encoded representation transformer from Google. That actually came out before the ChatGPT 2. And again, some of you might have already heard of it. So it's sort of like an early form of LLM. But I put a question mark there because at DevOps UK, somebody pointed out to me that that's not really an LLM. But, it's interesting when I'm doing kind of research, and that's what they call it, an early form of LLM. But yes, strictly speaking, if you kind of measure everything from the ChatGPT era, then maybe BERT is not quite qualified. But it's up to kind of kind of discussion too. But I just want to still set it up there because it's sort of kind of like, the early form of it. Now, if you kind of look further too, there are also codecs over here in the middle. That's what kind of formed the basis for GitHub Copilot codecs. And then there are also from Meta, Facebook is Llama 2, Llama, and there's also Llama 3. These are open source models too. And then of course, there's also like Mid Journey. I want to point out Mid Journey, Dolly, Stable Diffusion. These are text to image models too that came out of Stable Diffusion, came out of Stability AI. And then there's also a GPT-4, as we all know, that came out last year, sometime in the middle of the year 2023. It's an enhanced model from GPT 3.5. And then there's also Whisper, which is an audio-based kind of take care of audio type of data too. So again, these are just a couple of kind of representational ones. And of course, there are companies like Mistral and also Gemini, right, that came out from Google, that's multimodal. And also Cohere, for example, is another companies with kind of well-known models as well. And okay, so that's that. And okay, and then Stefano too is asking questions. Says, in your panel yesterday, also with Stefano and the other speakers, you mentioned about prompt engineering for getting better results from GenAI. Do you think the future versions of GenAI will be more intuitive, right? And sentient, so that it doesn't need more context to be able to understand conversation and context. I think exactly, Stefano. I think that's what I feel. Today's, prompt require us to kind of know what we want and then ask it in the right way. So to me, I think it's not truly Gen AI. I mean, it's not truly artificial intelligence, because the intelligence part is that you want the robot to be able to kind of think on its own. And really, sometimes too, when we need to decide on something, what to do, we basically want to ask the robot, hey, I can't figure it out. Can you figure it out for me? So writing prompts become kind of a chore in itself, in my opinion, right? Shouldn't it? So anyway, I think there are plenty of research being done. I wouldn't be surprised, very shortly we are coming out with even more advanced like prompts, that can kind of, essentially really moving the machines towards truly thinking on its own. So, but great question, Stefano. Thank you very much. So, okay, here, the next slide is about generative apps, right? So these are these are apps that are making use of all of the models. And of course, you yourselves too, some of you already started working with LLM apps. You are already producing apps that are relying on the generative models. But here are some of the example I already pointed out. For example, ChatGPT is kind of an app that's kind of making use of GPT 3.5 and also the 4.0, right? And then there are also other ones too. As you can see, highlighting, I want to say GitHub Copilot, and which also as developers, maybe a lot of us are using or maybe attempting to use it. And then also to wanting to point out to Gemini and Bart, they came out of Google as well. Gemini as such too. Actually, I might have put Gemini into the model side. Sorry if you kind of spotted it. But anyway, Gemini, the amazing thing about it is that from Google is that it's supporting multimodal. And I'll explain a little bit what modality means too. So, and then all of these other ones, they basically come from different companies too. They are apps that are making use of generative models as well. Okay, so here's the multimodal slide. So I think that's what is kind of making this super exciting, right? Is that, when we first started off like GenAI, it's basically text to text. You want something done, you talk to the chatbot and then give it some text. Let's say you spell something like, I want to know how I can, build an automobile engine or something, right? It goes back and then it comes back with you a whole paragraph, how do you build an engine like that? But the thing is, though, what makes it even more exciting is that, well, I want you to show me, right? How do you build an engine? And have a video, show it to me. So that's text to video. So that is actually where the true value of this whole thing is. You can do text to text, no doubt about it, but doing it multimodal is basically adding even more value to it. And you can also like show an image, right? Like a picture and say, well, who are these people in the pictures? And they should come back to you and show the text. Or it can say, show me, this actor, what movie he plays in, and it should do image to video. So you get the idea. So basically, there are kind of 6 main types, of modes or kind of modes. You can have text, image, code, audio, video, or 3D. So these things you ought to be able to do it. So then you can do multimodal type of kind of a transformation of data in between them. So that will actually make things even more useful for what we need, right? And basically, too, a lot of companies are also kind of into this kind of space as well. You may notice. So, okay, so now what about the people, right? All of the players. And don't forget, we are people, we're working with it. But I wanted to point out, right? There are data scientists, computer vision engineers. They are the ones that truly understand the data, what it is supposed to be doing. But very often, too, they are the ones who may not be developers or engineers, like maybe I assume most of you in the audience are developers developers and engineer. So the thing is too, if you kind of look into it on this side, right, the other side, and that one is basically they're data engineer, AI engineer, and ML ops too. Now, I just came from a DevOps panel. We talk about, integrating emerging technology. To me, I think this ML ops to machine learning ops, which is to me is an extension of DevOps into the machine learning space. I think there's a lot of potential in there. As we all know too, machine learning, there are kind of two categories of activities, right? One is the pre-training, like kind of broadly speaking, I'm talking about. There are many steps, small steps too, don't forget, but broadly speaking, you take the whole data, you need to train the model. So that's a huge task in itself. And then going to, after you produce the model, then you can do inferencing. And this is where you can apply this, what you're needing to search is you send the queries over to the model and get what you want. Do the chat completion is inferencing. So each one of them too, they take a lot of steps, so there are repeatable steps. We need to identify them, how to do some of these operational stuff. Now, not to forget too, data engineers, they still focus on the data, but they very often work with data scientists to kind of do all of the, so to speak, like the workflow, kind of like crunching data, all of these, but they are complex in itself too. So data engineer would do that, and then AI engineer kind of deals more on the AI kind of level. But of course, there are normal software engineers too. We still need to do, you take the data, you need to scrub them and then clean them, and also filter messages or filter all of the data and do all the feature engineering, for example. So just kind of want to give you an idea too. So do not worry, right? There are people that said, oh, it's going to take our jobs. No, I think we need more people to kind of make this more usable, more production ready too, is what I think. Okay, so really quickly then, let me go into all of the terminologies. GPT, generative pre-trained transformer. So basically, this kind of describes, right, what it does is it takes simple prompts, right, again, in human language form as input, and it does all of the pattern matching, and that's what we call like searches, similarity searches, and it answers questions for the prompts, and it produces content such as a new essay, a blog post, a computer program. That's GPT. And now, real quickly, is that GPT, how does it came about, right? It's essentially in 2018, and that's when the first GPT paper is about a language model that came out from OpenAI, and that was by Alec Redford's paper. And that actually captured a lot of attention because there are a lot of innovative kind of like research discussion in there, and based on pre-training, based on a large and diverse set of data. And then in 2019, is basically GPT-2 came out, and it expanded that all of the documents that it takes, right? It's GPT-2 also came out of Open AI. And then let's go to the next page. And so fast forward a little bit, 2022, and essentially ChatGPT, I kind of go a little bit ahead, it releases like GPT 3.5, and it's essentially wow the world since then, right? It's really hasn't been like, it hasn't been quite 2 years, right? A year and a half so far. And essentially it takes the world by surprise. And then, but not to forget to, I pointed out about stable diffusion, and that's came out from Stability AI. So it's essentially a deep learning text to image model that generates images, right, based on text descriptions. So it leads to like Midjourney and Dolly, and I'm sure a lot of you too, if you're trying all of the images things out, and those are kind of very popular model too. So as we can see, they came about then, and then 2023, then we see kind of more and more companies, vendors coming out with new models or new apps to like Bard from Google, and also Bing from Microsoft, and then all of these things are happening as we speak. So I won't spend too much time on that. Let's move on to the next thing, which is natural language processing. And that's what kind of all the magic that's kind of behind the scenes with the human language interpretation. So NLP, it stands for an interdisciplinary subfield of linguistics of computer science. So the idea is that it wants to process natural language data sets, right? And it takes, these data sets are huge. These are text corpora or speech corpora. And basically it processes that, and then it uses like rule-based and probabilistic machine learning approaches to kind of process, prompts that comes in, and helps essentially the LLMs to kind of produce what it wants, essentially. So it's essentially LLMs, large language models, will be using this technique underneath the hood, and it enables computer to learn from the contents, right, including, right, and these days too, we have to kind of move on to a next kind of way of thinking, is that we're doing like all of the contents that are produced. It's not just like what we used to. We need something, it's more definitive kind of answer. In this case too, with NLP, it's basically it can come back with a context of information around what you're searching for. So essentially too, it included, when you search for something, it comes back with some contextual nuances of the language itself. And it's essentially too, it can draw insights from the document. So it's pretty kind of innovative in that sense. So now let's kind of quickly take a look into LLMs, right? I mentioned about it. So LLMs, large language models, and that's what developers we work with directly, right? We interact with through all the libraries, all the AI APIs. It is a type of machine learning model. It's also foundation type of model. And we know that all of the general like LLMs, they cost a lot of money. It wouldn't be for us to do it because it takes, many GPUs and also weeks of processing too. And it essentially too, what it does is it performs all of the NLP tasks underneath, and it generates and classifies all of the text, and it answers questions, right? Answers all the prompts. It's basically feeding into LLMs to kind of for it to figure out what you want. It completes all of the chat, just like a human, right? Not only that, it also analyzes your sentiments too, and also dealing with chatbot conversations. Now, real quickly too, if you kind of look at this diagram, a picture is worth 1,000 words. So earlier I showed that set kind of theory, that onion. So if you kind of expand it a little more to include LLMs, and that's where it sits. It's the transformers, language transformers. It sits inside the deep learning space, right? So over here too, as you can see, deep learning has all the generative AI transformers in it too. There's image gen and also LLMs too, and that's where it sits. And as you can see, LLMs kind of leverages on NLP kind of techniques and all of the algorithms that's kind of working with NLPs, because the prompts comes in human language forms. It needs to figure things out. So a mixture of NLP. And as you can see, this whole diagram also explains is that there's also data science that are being applied, because AI is not AI without the data. So we need tons of data. So the data science, that's how it comes into play. Okay, so now you may be asking then, well, how can I actually work with LLMs? That all sounds good. So I just wanted to introduce to you a couple of these libraries. So if you want to kind of start working with it, these are open source libraries, are kind of open to all to use. LangChain, and you might have already kind of heard about it or worked with it already. So it is Python and also has TypeScript and JavaScript interface to that too. And that seems to be the most popular at this time if you search for some popularity kind of ranking, LangChain. And then also Llama Index is another popular one. And then there's also from Microsoft is Semantic Kernel. And that also has a Java SDK, because I come from more of the Java space. So it's really good to see some of the Java kind of like getting into AI, generative AI too. And then there's also Palm, and that's Palm came from Google, and that works with this Vertex AI. And then there's also Hugging Face. Now this one, in my previous panel, I brought up Hugging Face because we talk about, okay, GitHub is a way of helping, right, in the DevOps kind of process, because we produce tons of code. We need to version them and track them, all of these other things too, not just tracking, but a lot of things that can be done, right, with the source code. So how about like in generative AI space, we're talking about all of these models, generative AI models. So Hugging Face essentially allows you to kind of, you should think about of it like it's a repository that houses all of the generative AI models. So you can get an account there and download some of these models, but bear in mind that these models are very, very big, so make sure you have enough space and also like a large bandwidth to be able to download them. But there are also some smaller models too that you can kind of play around with, right? For example, GPT-2 has a medium-sized one that that's kind of reasonable size to it. You can download it easily. Now this one too, because again I came from Java. If you're a Java developers, and these are some of the API frameworks I like to recommend. There's LangChain 4J, and bear in mind it isn't the same as LangChain. These are different groups of folks, kind of open source groups working on LangChain 4J. I say that one is actually pretty good, kind of close to the, kind of takes the concept of the LangChain, and it's actually quite yeah, good to work with. If there's time, I can quickly show you. But otherwise, go to the GitHub. You can find out more information about them. And again, Semantic Kernel also has a Java SDK. There's also a JLlama too, which is like a Java port of the Llama, kind of uses the Llama models. But actually, because I know the author there, Jake, his name, and so yeah, he also actually supports other models like BERT, as well as I think there's also not just Llama. I think he said something else. So you can go there and take a look. And JVector, wanting to point out too, is basically a lower level libraries that kind of provides kind of with a vector API for Java. If you're interested, is here. And also llama2.java, that's a direct port from Llama C. Okay, so now this one, because I was kind of presenting to a Java crowd, so if you kind of want to take a look at, right, and maybe I won't spend as much time, it's just a very simple hello world. The idea is that you always want to get an OpenAI API key. So that one is also free of charge. You can register for OpenAI and then be able to then generate a key. And with that key, you can use, and of course, too, now that's another thing. We know that GPT 3.5 is actually much more cheaper than it is if you want to use GPT-4. So that's what I've been using too. So you can kind of use that API key, but of course, if you use that, then you're only working with 3.5. But so in this case too, you can just see, interacting with the model, you can just do a model.generate hello world, and it will print that answers out for you too. Okay, so now real quick too, I kind of realized I kept talking because this is such a a topic full of a lot of information, but I still want to quickly point out there's a retrieval augmented generation RAG concept that you might have seen also floating around in this space. And essentially too, what is RAG? Let's quickly kind of talk about it. It is a hybrid framework, right? It integrates two components of the RAG models. So essentially too, we have to think of data that comes in. We need to retrieve all of the data. So that's the retrieval model. And then there's also generative model side, in which it generates all of these fancy things that we're seeing in here. So the idea of RAG is that it wants to produce text, right, that is not only contextually accurate but also information rich too. So what does that mean, right? So let's kind of really quickly touch upon this retrieval model. Think of it like a librarian, right? It's a library. It pulls in relevant information from some sources. It could be a database, could be also corpus of documents, or like even a stream, like event stream that comes in a Kafka topic, for example. All of these, you can use retrieval, that model, to kind of do things. And so essentially too, with what you have pulled in, then you feed it to the generative model, because the generative model is what kind of seems to be the producer of magic, in which it acts as a writer, right? In a text to text kind of situation, it writes and kind of craft out cohesive, very coherent kind of information rich text, based on all of these retrieved data too. So essentially retrieval and a generative model work together in tandem to produce what you want. So one thing I want to point out is that this RAG pattern is only an architectural pattern, but it isn't actually tells it how you implement. You can implement in whatever way you see fit, but essentially it follows this model of having two components, the retrieval and the generative model. So now take a look at the generative model. As such, it is like a creative writer. It synthesizes the retrieved information and then produce for you like relevant kind of text to it too. So it's built upon like large language models too. So it's basically, it can create text that can gives you grammatically correct and semantically meaningful type of output too. And it's aligned with the prompt. And so now going back to Stefano's question is that, yes, currently too, you need to prompt, kind of set up a prompt that you have to know what you want, and you set up the prompt kind of like correctly. However, I think I see the future as the prompts, you can be a little bit sloppy and it should still give you like very accurate answers too, or maybe at least suggestions of what you can do with some things too. So essentially too, if you kind of think of in the RAG model, generative model is basically gives you the final piece of the puzzle, right? It's basically producing the textual output that we interact with. So that's RAG. Now, why is it necessary? Because if you kind of step back thinking, right, LLMs, as kind of humongous it seems like a huge monster, it can do things, but the input it gets, right, is some fixed set of data. Now, I'm talking about LLMs that are more general purpose, right? ChatGPT 3.5, 4.0, whatever it is. So it needs time to produce, to train the model. So as such, for example, the ChatGPT 3.5, it came out in November of 2022. It only has processed data up to 2021. So you may be wondering, what happened now? There's data. Data doesn't take a break, right? It keeps coming. So all of these data in between, the time that you produce your model and the time that it's cut off, then what to do. So that's when you want to apply a kind of mechanism is using the rank model to be able to feed to your kind of to augment. That's what it's called, augmentation or augmented model, because it augments the answers, because the LLMs doesn't have the answer, but you want to feed in external data to it. So that's when you use RAG model. Okay, so now finally get to the vector database similarity searches, although I realize I only have 5 minutes, so I'll be real fast. Okay, so what is vector database? So now, if you kind of look at, LLMs is basically a static piece of humongous set of data, but it doesn't know, it doesn't remember things. If you ask it something, you just ask it and that's it. And where does it go, right? How do I store? Like very often in real production, kind of environment, you want, you're doing queries, it's like you're going into a store to ask for help. Somebody is helping you. They do not just help you and say bye bye. The thing is too, you need to buy something, you have lots of questions back and forth, you test something out, you ask more questions. So LLMs can't do that by itself. So that's why maybe you want to consider some storage mechanism. You can always do things in memory, but that will be very limited because your memory, no matter what it is, it can't hold everything in the whole world. So that's when you want to consider storage, like a vector database. So vector database is a purpose-built database that serves up vector data type for complex machine learning purposes. Now, remember I said that essentially too, this generative time, right? Generative AI is that you're dealing with contexts that have multiple dimensions. And what does it mean, right? So essentially, you want it, the data to be able to figure a lot of things out. It's not just returning to you like, kind of like apple and apple, orange is orange. But maybe you say, what is it about an apple? You can return a lot more things. There are many varieties, all of these things, right? So all of these kind of the capability is basically can be enhanced by using a vector database, vector search, because you take the data, first of all, you work with a vector database, you take the data that comes in as input, you need to basically transform it into what is called embeddings. So embeddings are numerical representations of the data that are stored in vector database. So if you kind of look into it, it's basically they are arrays of floating point numbers. So in other words, that you need to rely on a model. So that's what is called embedding model, that you want to say, I want to convert the data using this embedding model. So with that, it's stored into your vector database. And then when there's a query coming in, you may be saying that I want to look for an apple that's kind of delicious and all that stuff. And it might kind of go back and kind of do all the searches and say it returns you the red delicious apple. It's truly delicious. And so it does all of these things and may suggest to you, well, pink lady is also delicious too, but maybe a little bit sour taste to the red delicious, for example, something like that. So all of these kind of way of allowing it to be search and kind of giving you all the context is relying on vector database. Really quickly too, if you want to take a look at vector data I'm using a graph to describe it. You can have many dimensions too, but for simplicity's sake, I'm using a two-dimensional kind of space to describe to you. So you can have data. The data itself is not just the data, but what is called in mathematical terms. If you are familiar with linear algebra, it's basically vector data has a magnitude and also a value to it too, right? So essentially, too, that's how you can plot it on a graph, a two-dimensional graph. So V1, V2, and 3, 3. So let's kind of take a look at the next example. It can be a cat, a dog, and a house. So let's say cat and dog are already stored. That's where they live in that space. And you want to kind of search for something like what is in the house, and it can come back to you. What is closest is the dog in this case, because usually dogs are more loyal. They guard your house. They don't go outside like cats do during the day. So then maybe that's why the dog can be returned to, right, in your searches. So again, this is just really, really quickly kind of describing to you the mechanics of it. But here I won't get into all the details, but if you are interested, essentially to vector search will not just like do that linear algebra, just one dimensional thing, right? One simple thing like that, but it's essentially go through different layers too. It does a lot of computations between different layers, and then it kind of sort them all of it and gives you the answers that you want at the end. So that's what all the magic is existing behind the scenes. Okay, so examples of vector database. These are open source, and I like to, this I actually take from an OSS ranking site. MILFs appear to be quite popular, and PG Vector is an extension of Postgres. That's something I'm kind of working on a workshop too, if you're interested. And there's also Chroma, Fast from Meta or Facebook, also Quadrant and Weaviate. Actually, there's another Weaviate developer advocate at this. Daniel is his name. If you've been to his talk, that was very good too. So these are kind of example of vector databases that are open source that you can consider using. And what are vector embeddings being used for? For searches, for clustering, for recommendations, anomaly detection, diversity measurement, classification, you name it, right? So these are kind of very promising type of works. But of course, it's not as simple as you think to use it, but once you figure out, it's not bad. Okay, thank you. Stefano said 1 minute. So just wanted to point out traditional database, you can use it too, but then it doesn't know how to handle a lot of the dimensions, patterns, and relationships, as well as vector database. And the vector search is using like linear algebra mathematical algorithms to do it. So it can do things a lot faster in that sense. Okay, so this is just another example, a picture of a RAG application. If you're interested, I'll share my slide deck with you. Really quickly, benefits, as we all know, you can see, right? You ask and you shall receive, but make sure to ask wisely. However, make sure that you are aware of hallucinations, right? LLMs are not magic. It can come back with wrong answers, or sometimes too, we don't even know. There could be ethical concerns. There are no regulations to all of these usage of LLMs right now. You can produce your own private LLMs as well. But how about real-time up-to-date data? As I point out, you can use a RAG pattern to kind of augment what LLMs are missing too. So with that, I think I'm kind of timed. So if you're interested, this is okay, I better like step back a little bit. If you want to take a quick kind of picture of this QR code and also the bit.ly kind of URL to it too. Now, if you miss it, don't worry about it. And there's also some sharing, the open source ranking information for the vector search engine if you're interested. And also, I have my own stream too. If you want to join me, I'm trying to get back to it. My Twitch channel, please follow me there. And also multi-stream to YouTube as well. And with that, I want to thank you and let me kind of walk away. But you can find me on LinkedIn. You can find me on Twitter or the X, and also my Discord channel too. Let me real quickly kind of get myself kind of move myself away so then I don't block it. So okay. So this is how you can get a hold of me, but I ask you to stay in touch with me and share with me your projects. There's really exciting thing. So thank you, Stefanos. Thank you, Dev Days Europe. It's been really fun here, even though it's like virtual. It's been kind of fun to interacting with a lot of people. And please feel free, everybody. Follow me and give me feedback and share with me your projects on GenAI. Thanks a lot. Bye. Yeah.